Now we're going to talk about some one-sided limits. So one-sided limits, we have right and left-sided limits. So the right-sided limits, we're interested in approaching a value from above. That's what this plus sign indicates. And limits from the left are limits where we're approaching the value from below. That's what this minus sign indicates. So here we are attempting, oh, wait, hold on one second, let me move this. Okay. So we're looking at a few examples. We're taking one-sided limits. So in this particular case, we have, this function g. We don't have a formula for g or the equation, the piecewise defined equation that defines g, but what we do have is the graph of g. So the first item of interest here is g of 2. Now x equal to 2 is here, that's the domain value, and you can see this is where 2 is not mapped. That's indicated by this open circle. This open circle indicates this point is not on the graph, but this closed circle here indicates that point is on the graph. That point is the ordered pair 2, 3. 2 is in the domain, 3 is in the range. 3 is the image of 2 under g. So g of 2 is 3. So next we want to look at the limit as x approaches 2 from below of g of x. As x approaches 2 from below, that's this set of points. We'll look at a sequence of points that's strictly smaller than 2. Those points get mapped via the function g to these points on the graph, and the image of those points, or their y values, those points gets as close to 2 as we want. So the limit as x approaches 2 from below of g, that's 2. What about the limit as x approaches 2 from above of g of x? If we take a sequence or look at a sequence of points that's getting closer to 2 but strictly larger than 2, those points are mapped via g to this part of the graph, and the y values, I hope you can see that, this part of the graph, and the y values associated with these points, they're all 3. So the limit as x approaches 2 from above of g of x, that's 3. So when we ask what's the limit as x approaches 2 of g of x, well, we see the lower limit is 2, the upper limit is 3. The limits exist, but they're not equal. So since the limits are not equal, this limit does not exist. So I'll just put DNE for does not exist. Okay, moving on. G of 3. What's G of 3? So 3 is here, and the image of 3 is this point here, this filled in point. This point is the ordered pair 3, 2. 3 is a domain value, 2 is the range value. 2 is the image of G, 2 is the image of 3 under G. So G of 3 is 2. Now we'll look at some one-sided limits. Like before, if we look at the limit as x approaches 3 from below, we're looking at values of x smaller than 3. So smaller than 3, we look at this sequence of points. The image of those points under G is mapped here on the graph. The y values for those points are all 3. So as x approaches 3 from below of g of x, that's equal to 3. What about the limit as x approaches 3 from above of g of x? Well, as x approaches 3 from above, if we look at this sequence of points, these are all values that are larger than 3. The image of these points under the mapping is here on the graph. And the y values for those points, well, that would be a sequence of points over here getting closer and closer to 2. So as x approaches 3 from above of g of x, that's equal to 2. So the question's not asked here, but we will ask, what's the limit as x approaches 3 of g of x? Do you know? You should know, because that's what we just spoke about a few minutes ago. Since these limits, they both exist, but they're not equal. So since they are not equal, this limit fails to exist. We can just write does not exist here. Okay, what about g of 4? g of 4, well, 4 is here. 4 is here, and the image of 4 under the mapping is 3. So this is the ordered pair 4, 3. 4 gets mapped to 3, so g of 4 is 3. And what about the limit as x approaches 4 of g of x? Well, this part of the function, unlike the other points that we were interested in, at x equal to 4, this function is what we will call continuous. We'll use that language fairly soon in the course. Continuous here means there's no breaks, there's no holes, there's no gaps, and it's a smooth function here. So the limit as x approaches 4, from below, from above, it's the same. That's going to be equal to 3. So the limit as x approaches 4 of g of x, that's 3.